Good evening, folks. My name is Prashant. I'm part of the OWASP Bay Area chapter. Along with other team members, Travis, we manage this event. This particular event is called Hacker Thursdays, which we do it on every other day except Thursdays. Today we have a session from Gábor and Mark. They have come from Hungary. It was very nice of them to contact us and say that, okay, we want to take a session for you guys. So it was very nice of them, and I hope we have a great session. Also, thank you very much, Trolia Group, Annie, for organizing this and giving us this beautiful venue. So without taking much time, let's get started. And you want to speak? Yeah. So the password is turn on the lights.
So hopefully you should hear me. Is it better? Okay, great. So thanks for coming. My name is Gábor, and I'm going to talk a little bit about the recent security breaches that you might have heard of from the news. So just a small disclaimer. I try to give you a little bit of about the breach and the bugs behind those breaches, but we also have some challenges that would like you to solve those. And so the entire session is about giving a story, and afterwards we give you a bit of information about the challenges. So right. So a few words about me. I'm the co-founder and CTO of Avatar. This is the learning platform we are going to use today to solve the security exercises. I did my PhD in virtualization, security, and malware. So this is not a topic I'm an expertise in, but I prepared myself to be ready for this talk. So yeah, and the one more thing which worth mentioning is that I'm one of the founders of the Spellantech CTF team. We founded this in 2013, and in 2015 the first time in the history of Hungary, we got into the DEF CON CTF finals, and 3 times in a row we get into the finals in 16 and 17 as well. And many other CTFs participated. So we are going to discuss today 4 breaches. The first is Equifax. Afterwards, we take a look at the Facebook breach that was just recently. And afterwards, we touch the British Airways. And finally, we finish with Yahoo, which was actually, Yahoo was the biggest breach ever. So 3 billion user accounts were leaked. And we don't know any technical details about this breach, but we are going to find a problem in Yahoo Mail. So let's go back to Equifax. All right, so this is a story I don't have to introduce because everybody heard about this. 2017, July 29, Equifax team discovered a security leak. And the leak the leak affected 143 million user accounts and their social security IDs. In the US, I think I don't have to explain what it means. So it's a really, really huge breach. And actually, everybody who gets hands on this data can basically do whatever he wants with the user actually who owns this information. So the vulnerability. So everybody knows that Equifax used Apache Struts. This is an MVC framework, a third-party library, and actually many of the Fortune 100 companies use this framework because they build on Java, and this is a really convenient way to deliver our applications. So we are going to take a look at 2 bugs. I just mentioned the first one, which actually was a Jakarta multiple parser bug on March 10, 2017. This was the bug that actually the attackers misused, and as a result, they could steal the information. In that case, they could manipulate the content type header, and the OGNL engine, this is the Open Graph description language, or I don't know exactly the acronym, but the thing here is that this was a command injection. So through the content type header, you could directly inject a command that the Apache Struts server, actually this parser, could evaluate and execute the command directly. So it's a really simple thing, right? Because we simply just inject something, you break out of the context of the parser, and afterwards you can just trigger the command that you injected into this context. So it's a simple thing. You don't have to think about super 0 days in Chrome. The second one is it was also in our Struts plugin called the REST plugin, which means representational state transfer. I don't have to introduce it. Everybody knows what it means. So the thing here is that it used an XML formatted data converter plugin called Xstream library. And actually, this Xstream library is known to be vulnerable to unserialization, deserialization attacks. At the same time, there is a disclaimer on the website that this is insecure. If you directly pass them Java objects, it's going to disassemble those objects, and you can control the type, the data in these objects in order to trigger any kind of attacks. We are going to check this bug today. So, as I told you, in the Xstream plugin. So the problem with this plugin is simply, as it says, that you can encode any sort of Java data into a Java object that afterwards you are going to unserialize. So as a result, there is no type constraint, there is no whitelisting, there is no limitation what kind of primitives you can handle. You just simply pass the information afterwards. It's going to end up in a read object context, and it's going to be parsed. So this is how such a deserialization looks like. So the very first thing, we just define an input stream, and afterward we read from the input the serialized object, and afterwards we just simply define a new object input stream and call the read object function. This is real simple, and this read object function can be actually misused in certain scenarios. Of course, deserialization is just not only this one. So any one of you can tell me other examples how this kind of problem can be misused? Look, you, for example. Not you, Julia. So deserialization attacks, please. How many of you heard about this? 1 hit, 2, okay. Half of the team. Okay, back there. So what does it mean? Yeah, but for example, could you tell us an example where this kind of problem is represented? So just you have an object, and what is in the object? So what is inside? Yeah, so exactly. Actually, there are two misuses that now I mentioned. The first one is you just simply insert text that, for example, allows you as an attacker to do a privilege escalation. So, for example, it expects a simple user, and if the input is this user, you can do this code path. But if you modify this text and change it to admin, for example, you are going to do a privilege escalation, and afterwards the code is going to take another path. So this is a kind of attack inside the context of the code that's being there. That's inside in the target application. However, you can create a gadget, and in the gadget, you can also inject a new code that allows you to run arbitrary code on the server. We are going to take a look at this now. So this read object example is something like this. You have an application code. You just read the bytes with this. So yeah, as I said, so you initialize the object, input stream, and afterwards you are going to call the read object. As a result, the read object is going to resolve the class that it gets as an input. So you have a Java object. The Java object is parsed by the read object. Read object is going to resolve the class that is inside this Java object, and afterwards it's going to deserialize the object. So it's going to touch every member method and every member attribute in this object. So as a result, this read object here is going to be called. And the problem is that, for example, if you have an employee class, for example, this is going to be our first challenge. it's going to be similar to this problem we will see. So if you have an employee class and it implements a serializable class of Java, and you have a string name something like this, and what you do is to override the original read object method in the gadget, in the payload that you are creating as an attacker. You can simply call this default read object method. As a result, you initialize the read object content. So this is what you have to call on your own. And finally, you can define what method you would like to you would like to run. And in that case, the name is going to be executed as a process, as a new command. So what does it mean? If this is your payload that you inject into your target server, it's going to deserialize this object because you have to compile it, of course. So this is a source code. This is a Java class. You compile it. You are going to have a byte stream. This byte stream is going to be passed to a server. The server is going to disassemble it and is going to evaluate all the member variables. And finally, when it's going to call the read object, it detects that the read object of this class is going to be called because there is a function that is here. So as a result, it's going to trigger a code execution on the input that we created. Could you a bit loud? No. This is the gadget. This is the payload that you inject. Yeah, exactly. It comes from this is what you serialize as an object. It has many variables, and this is the Java object that you inject into the target server that's going to deserialize this object that is compiled. And during deserialization, you see that it's going to restore the object member fields here. So the read object is going to be called, but it sees that the read object has been implemented in this employee. So not the original read object is going to be called, but the one we provided. So as a result, it's going to trigger the command execution.
There's an example for that.
Okay. A similar example is going to be here, but not this one. Yeah, so actually, OWASP, the problem is that there are many functions actually that shouldn't be used for deserialization because these functions are just simply vulnerable to any kind of attacks like this. So actually, I just checked the OWASP guide what to do in case of deserialization, and the main takeaway is don't try to deserialize a Java object or any kind of object on its own, but please use primitive types. So this is the most effective way to evade these kind of attacks. All right. So challenge time. Please prepare yourself. We are going to solve our first two challenges. And to do this, the only thing you have to do is to please type into your browser platform that, okay, I just opened a new browser. So platform.avatar.com. Platform.avatar.com. Can you see this? Okay, I tried. Oh, I don't know. Maybe here. Is it good? It's here, downwards. It's here. Yes. Turn on the lights. One word. So hands up, please, if you found the URL. Good, good. In the corner, everything is good? Okay. So after doing this, please click on the sign up button here. And just give a nickname, an email address, and a simple password. That's all, and accept the terms and conditions. I do this again. Please let me know if you are ready. Ready? Good. So I sign up. And please type into the browser OWASP Bay Area. The search bar. Should give you one hit. This is a community we are going to join, because this learning path, which we are going to exercise on, is part of this community. So OWASP Bay Area in the search bar, and just find the first community. The only thing you have to do is to send join request. Click on this button, and I'm going to accept this join request. So we will allow you into this community. So this is the easiest way not to request any email addresses. Oh, great. Done. So if anybody is still waiting, please let me know. Otherwise, we can move forward. So into the search bar, just please type anatomy. This is the name of the talk, and you are going to have one hit, one learning path. So this should be something like this. good. Exactly. So afterwards, you should see this. We have 5 exercises. These are the ones we would like to solve today. We will see if we have enough time. So please let me know if everyone, who sees this? Hands up. Anybody? Still waiting for? You? No? Okay. Let's start it. So the first challenge is called You Can't Touch This. This is a simple, super simple example. This is a Java serialization problem. We have an employee.java file. All right? And this is actually this one, what we see here. I give you a few seconds to check this file and read the text. Please do this. And afterwards, we move forward. Yes? 2 more requests. Great. Good. All right. So what is the problem? Can anybody tell me? So what is the task? What should we do? In the back. You. No. I ask you, so what is the exercise about? So what should we do now in order to solve this? So the thing is we have to acquire a flag from the server by creating a little exploit. It's actually not an exploit. This is just a simple code that we have to create in order to retrieve this flag from the server. So just an idea. What is this threat handler? So how should we proceed, move on? How should we move on from this state that we do not know anything? We have a server, we have an IP address, a port, we have to NC there, and so there's a flag there at the server, and they somehow would like to just steal it. That's the challenge. Just please, just idea. Just throw me the ideas, that's all. Yes, but the only problem is that we first somehow inject this code into the server. And in this way, we have to find a bug that we would like to exploit. This is a simple exercise. We don't have to exploit the server-side bug, a server-side byte. So just to move forward quickly, the solution here, I show you because we have many other exercises, is that I try to move. Okay. So what we have is the employee Java, right? Like this. So this is the employee Java. That is what we downloaded from the server. And what we have to do is to create a bytecode from this server. So from this class, so we have to create an object, a Java object, and by filling the name field and the age, so this has to be hacker, I don't know what exactly, hacker Joe and lead. So this is what you have to just set these two fields. That is the only thing we have to do. And just throwing it to the server, it's going to respond with a flag. So this is the idea. It's a simple one. So I prepared the solution. Just show it here because it's larger. Okay. So what we have here is the first solution. Is we have to just simply create a new employee object. We are going to initialize it with the right values. So it has to be the one we have in the exercise. So this is Hacker Joe. Hacker Joe lead, we have to provide the IP address and the port of the application. I close this. I don't make this anymore. Which is here that we started. So we have an IP address. And we have a port. It's actually the same now. So we just print something out that we start something. We are going to initialize an input stream. We are going to put out, initialize the input stream. We are going to read in the values that we are going to provide it. And by creating an output stream, we are going to write an object that we are going to send directly to the server. And we are going to wait for the response. So this is what we are going to do. These are the simple things we are going to do. All right, so let's do this. We have to just compile these two files together. Here we are. And we just simply run the solution like, let me check. Solution 1. Okay, I have to save it. And I have to recompile it. Okay, here we are. So, do you understand what happened? So basically, we just constructed an object with the right name and age. We pass it to the server, and the server responded with the flag. So this is a simple, super simple exercise. So this is what we copy, and we provide to the platform. We check the solution, and we are done. We can rate it. Okay. Yeah, this was not a vulnerability. That is what I said. So okay, if I go back to the, so GitHub, I'll show you the source code. So this was just an example of how to serialize an object, which is going to be deserialized at the server side. So this was not a real bug inside. Because I wanted to just prepare the Equifax bridge, so just to understand how the serialization and deserialization works, that's all. But I can show you how the, so if I go here, you organization, you can touch this, and source code, server.java. So this is the source code of the Java, that the server that runs on the IP address. So what it does is basically just simply, please send me an employee object, and it calls the read object that we mentioned previously, and basically it checks whether the resulting, the deserialized object has this Hacker Joe and this lead name, lead age. So that's all. This is just an example. Now we are going to check what was the problem with the struts. All right? So this is the struts bug. Please read it first, and afterwards we are going to move forward. Yes. Actually, it just restored an employee object from the, you have a serialized Java object that's passing through the network. And afterwards, the deserialized, the read object function is going to read this Java object, and it must read, actually, this not real Java object, but serialized object, and afterwards it's going to call the read object in order to deserialize it, so create a real Java object inside the server. And afterwards, it just read whether the name attribute contains the hacker geo and the age equals to lead. That's all. Exactly. That is what it does. So, and you can imagine that if, as you said, as you saw, there is no input validation, nothing here. So it is just this. It is just, where is it? That's just this. It's in a try-catch block. So this is the only thing it does. So here I can do whatever I want. Because later on, if, for example, this get name is not get name, but a command, and it's going to call an exec on this command, on an eval, or something like this, I'm done. And if it is not whitelisted, if it is not controlled in certain ways, I can pass any kind of value which is going to be evaluated as a code that the server is going to execute. So this was just an example to understand how this kind of attack model works. Serialized object, deserialized, and afterwards it's executed. And actually, going back to the read object, is, so here we have this read object. Yeah, it's here. So the problem with the read object is that if the employee object overrides this read object, the read object won't call the original read object, but the one I overrode. And if I put there any kind of, I can do whatever I want. So this one is actually simple. Let's go back to the script. This allowed the attackers to actually do a remote code execution. And if you check the Python code that was provided by this guy, looks a bit weird, right? You have a payload with binaries and things like this. But if you just quickly pass the code, you realize that it is quite simple. So what it does, anybody can tell me what does it do, what it does? Simple, super simple. We have a main, right? And afterwards, we are going to parse the inputs. We are going to check whether the parameters we provided are correct or not. And at a certain point, we first check whether the server is vulnerable, this one. We have a URL. We have a URL, the target URL, where the vulnerable struts engine is running. And we check, this is my intuition, that is what it does, because this is, who knows? But I say this is a fingerprinting. So we check whether the server is vulnerable, so it contains the right version, like what embed does. So it just gives a fingerprint, and if the server responds with the correct answer, we know that this is a problem. So this is what we do. We check the server version, and if everything is correct, we are going to call the exploit function. So in the check, we are going to call the exploit function, and the exploit function is going to do this. So here we are. So basically, we would like to pass a command line argument to this exploit function that we manipulate, and afterwards we embed into the payload that is here. So this is going to be, this XML is going to be evaluated on the server side by struts, right? But it looks a bit obfuscated, but it is not actually. If you check what kind of things we do, it's just going back. So here we are. This is the command we would like to execute. And this command is actually embraced into what? What is here? Spawning new process. So we spawn a new process, and we are going to execute something that the user provided, right? So here we are. And afterwards, we are going to do some other things, which I don't understand because I don't know what is this. But the main idea here is that we just simply do a similar thing. What we did with the read object stuff is that we embed a command, and we create a context for the command to be executed. So we create function calls like process builder, collection empty iterator, filter iterator. So we are just preparing the context to execute something, right? So this is what we do here. And actually, the challenge itself, just wanted to go through this file because it doesn't make sense to execute a script, and we do not know what it does. So please try now to execute this script, download it. This is in the exercise, and try to get a flag from the server. I'll give you a few minutes, all right? Yes. So how I understand the payload is you have this XML, as you said. This is what passes through the network to the server. It's going to create a read object, as we saw it previously. So it's going to parse it, and it's going to so what we saw, for example, at the read object, what we injected directly into the employee, it does it with the XML. So it creates the context, so it's going to maybe inject a similar read object, but it's a process builder, and these filters, this filter iterator, this null cipher, and these things. So basically, there's a bug inside struts in this plugin, in this REST plugin. And this REST bug, this bug can be triggered through these kind of functions. So for example, this cyber input stream, the null cipher. So there must be some kind of crypto problems in this REST plugin. In order to trigger this bug, you must call the functions that lets you to go to the vulnerable, to the real bug, because you have to be in the context, in the right path at the application in order to trigger this bug. If you don't set up the context, you just cannot reach to run an arbitrary command. So that is what you do, I think. No, you cannot, because, I mean, maybe you could, but in this example, the point here is, no, I think in that case, no, because the Xstream plugin is vulnerable, so you must provide an XML to this plugin. Maybe it accepts JSON as well, I don't know. But the point here is you must provide something that is serialized, and in that case, this serialized object is going to be deserialized by this XML Xstream plugin, and this Xstream plugin evaluates these kind of tags in the XML as a function called something like this. Exactly. Exactly. This is my idea. But if anybody has a better idea, just let me know. But I think this makes sense, as you see, because at certain point there's going to be a process builder, so you must spawn a new process that you inject to a command. So for the command that you injected, but in order to trigger this process builder, of course, you have to set up the context. How you set up the context? To take the right path in the application, which triggers the bug. In order to trigger this path, in order to go through this path, you must call certain functions with certain attributes. That is what you provide as an input in the XML. So anybody, any idea how to proceed? Please, hands up. I'm going to select somebody in the first row. Yeah, please. What's your idea? Why? You have the script. So first, when we try to misuse a bug, right? We have to first have an abstract attack model in our mind. If we just go into the details of the scripts, it doesn't make any sense. We have to have an attack model in our mind. So what is the attack model? We have a script that we know which can be used against this vulnerable server. We have a server with an old version of struts. The REST plugin has been enabled, so definitely there's a way to trigger this bug, to somehow misuse it. We don't have to create the exploit on our own. We have the script. So what we can do with this script? Please let me know. So if go back to the README, that is what I would do. Here it is. So we have to just provide a URL. We have the URL because we launched the exercise. Then we have the URL, so we are here, right? So this is the URL we are targeting. It's a unique URL for everybody. All right. So the thing here is what we can do is to run a command, -c, right? So any idea now? Maybe you, the first row. So we have the URL, we have the command that we can execute, and the only thing we'd like to do is to acquire a flag that's sitting on a server. That's all. How to do this? Just please let me know how to do this. So there's a hint in the exercise. So this is how we check the solution. There is a flag.txt under var flag. The solution checker just reads this flag and check if the solution that we submit here equals to the flag value that is in this file. This is the only thing it does. We have a script. We can run arbitrary command. We have a URL. So what to do now? The only thing we have to do is to acquire the value of flag.text and submit it to the platform. That's all. Simple. Why? How? Super simple. Two execution of the script. Two. Great. But how do we get it back? Sorry? What? We can get it. But how to get it? Yeah, but you have to stream it back from the server to the client side. As a? No. On its own, why would it work? If you just say that cat var flag.txt, what it does, it prints out to the server side that actually we cannot see. And then? What if we have a server? You would like to, maybe this flag can be accessible only to the server. If you, for example, do something like this, maybe we need to open a new port that we can NC into. But what happens if this port is just filtered? We have a firewall, and actually this is the only port that we got. This is HTTP. Everything is disabled. Actually, I'm sure that it's disabled, so we cannot go into it. All right. So the solution, the simple solution is, what if we just simply delete this flag, delete, and touch it? And the solution is empty. Let's do this and try if it works. Okay. So I have the URL. I'm going to find an order, because if you check the application, there are orders here. And the first thing we are going to do is just to remove this. Done. And we touch it. Done. We go back. This is not what I read from var.txt. So maybe this is not the good solution. This is. So, okay, what I didn't mention. So if you get stuck on Avatar, there's a hint line. You can check it. So on normal challenges, you can always get this guideline. you have to pay some points because every challenge comes with a score. As you see, this is 50 difficulty, so it's quite easy on a range until 500. And you can get a hint when you feel that you cannot move forward. So yes, actually the solution should be good. The only thing I missed is that I didn't provide the right URL, which is orders. So let's remove it first. And afterwards, we are going to touch it again. And now, yes. Okay? So, any questions? Please. Yes. Yeah, you run the same command. I mean, first you remove it, and afterwards you touch it.
No, so I was just using the same script.
Yeah, exactly.
It says it's not vulnerable.
Yeah, exactly. So that the script just misuses one bug on the server side. That's all. Was it the question? So, yeah, you can.
I run this command.
Yes. You forgot to add the -c. -c, and you have to provide what
exploit I want to do.
Yeah, exactly. So you have to just first remove the file, var flag.txt, and afterwards you have to retouch it.
There's a vulnerability assessment and tells you whether the version number of the struts is vulnerable.
Yeah, exactly, something like this. So without the command, it just checks whether the struts application is vulnerable or not. Yeah. Okay. Anybody problem with this kind of stuff?
I executed so twice. I'll up the. So first time I touched it.
Oh, you don't need the URL. So okay. Thanks. So please take care of the URL. I go back. So the URL. Here we are. Look, please, everybody, check whether the URL is correct. So it comes with an ID, Lupus, for example, or any kind of server, avatarchallenge.com/orders/an ID. All right? No XHTML or any kind of thing. So it must be the API URL. All right? ICE. Could you solve it? Could you solve it?
I'm not working on it. It's working on it.
Python 3. Yeah. Okay. Is it fast or good, guys?
Huh?
Is it fast?
Is it fast?
Is it fast?
No, I just we didn't know what kind of.
Yeah. It's not clear like what needs to be done or what needs to be done.
Okay.
Probably in the future, if you can
Okay, this is the only challenge where we need to run these local things. Okay, the other ones are going to be easier, so you don't need any kind of setup. Yeah. Yeah, makes sense. Okay. Yes. Do I have a? Yeah, exactly. So it's like orders/3 in that case.
Like I was just using
Yeah, without orders of H. X.
When I was running that,
Orders. Oh. Is it good now?
yeah, it works.
Okay, great.
So I wanted to make sure that it didn't have to be a
Okay, that's good. That's good. Okay, so it works without the orders page as well because the Struts server serves everything. All right. Sorry if I didn't say that you have to have this request and some kind of libraries installed for Python. This is the only challenge where we have to run something locally. So I suggest to move forward because we have 3 more topics, and after the workshop we can move into the details, right? Because we won't have time to touch the other bugs and breaches. Okay. So okay, the takeaway is the first: don't parse serialized objects from untrusted resources. So this is the most generic advice we can give to anybody who tries to do anything with Java or any kind of objects. And restrict what kind of types you enable. Primitive types are the best. And use whitelists, because whitelists are going to restrict what kind of inputs you expect, and you can accept only those. And if the type information is also there, this is really good. And also turn off those features that you don't use, because, for example, in that case, this REST plugin could have been disabled, and of course, the attack surface could have been minimized. So always think to minimize your attack surface by disabling the don't use plugins. And also, I suggest, this is not a marketing, but you can use Snyk or Black Duck or any kind of third-party library checker tools, automated tools, in order to continuously check whether there is a third-party dependency that has a known bug. All right? So this kind of stuff should be, for example, part of your CI/CD pipeline. Just before you release something to production, just run Snyk against those things, or Black Duck, or whatever tool you use. Third-party libraries should be checked. Some readings here, so just please check it. Let's move forward to Facebook. All right, so the breach is really, really recent. Everybody heard about this, I'm sure. And 50 million user accounts were affected, and depending on the account, the attackers could steal different information like username, contact information, gender, language, birth date, things like this. So the problem is that in July 2017, they created a new video upload feature, and this video upload feature could trigger 3 distinct bugs. So the vulnerability comprises 3 bugs, and by misusing these 3 bugs in sequence after each other, we could retrieve this kind of information from Facebook. Facebook said that the feature is disabled now. Theoretically, they fixed it. This is what they say. We don't know. And they reset 40 million access tokens. So this is what they reported in their official statement. So the first bug. The View As feature allows you, the View As feature means that as a Facebook user, I am interested how other people looks at my product, my profile. So for example, I can do this only on LinkedIn. So how I am visible to others on Facebook. So this feature actually allows you to upload a video. Actually, in this feature, there is a happy birthday feature. So you can wish a happy birthday to somebody through this View As feature, and you can upload also a video. So this is the thing. And the thing here is that when you upload a video, this video uploader is going to generate an access token with the permissions of the Facebook mobile app, right? So we generate an access token. We are going to discuss what an access token is later. But let's now accept this, that we create an access token. Facebook creates an access token, and this access token comes with the permissions of the Facebook mobile app. Bug number 3. This access token wasn't for us, but for the user we looked up. So basically, we have an access token for each user. We check with the view as feature. And this access token is actually something that the user acquires when he logs in to his own account. It's really good because we can script it, right? That's why 50 million users can be lead. And the funniest thing, because access tokens works in a way that we must acquire the access token on the client side, in the HTML, it's embedded. So it's really easy to acquire these access tokens. OK, so moving forward, JSON Web Tokens. Who knows what it is? Yes. So JSON Web Tokens were figured out to replace, or let's say not just to replace, but to simplify, first of all, session handling, to make it more scalable, because to store sessions on the server side makes it difficult to scale, for example, in a microservice architecture. So they thought that what if they put this kind of burden to the client side? So this is when the access token comes. And how it works is we just simply log in to a server. After successful login, we are going to acquire some access tokens. It's going to return it back to me in his response. And afterwards, I can use this access token as information that proves that I have valid credentials to this system, and I can afterwards access restricted resources without logging in again. All right? So by having this signed secret, I can go into a resource, and the resource is going to allow me if this access token is valid or not. So in case of JSON Web Token, this is how it is built up. We have a header where we define the type of the token. We define actually the algorithm that we use for signing. We have the payload that we'd like to just pass to the server, and it's going to check whether this information is good or not. And we also provide a signature, because the signature must prove that this payload and this header hasn't been tampered or modified while traveling to the restricted resource. So on glwt.io, actually it is managed by Out0, you can find a simple JWT token decoder and encoder. So in this example, you define that you have HMAC with SHA-256 algorithm. So what it means, anybody? HMAC with this hash function means that yes. So what's the difference between a hash and HMAC? Yeah. So what's the difference? Exactly. So the key here is the secret, the password. So it's main keyed hash. HMAC is a keyed hash. So in the hash function, we also provide a key, a secret that only me and the server knows. In that way, I can make sure, the server can make sure that if a message comes from me, then this message is really the message that I sent. It doesn't mean that it comes from me, because if it's not digitally signed, it doesn't mean that it comes from me, but it makes sure that the message is the one that I sent. Okay? So in that case, the signature generation works in a way that we create a base 64 encoded header. So we just encode this. Afterwards, we are going to encode a payload, and we pass a secret. I don't know if you see it. I kind of zoom here. But there's a secret here. This is the signature, and this is going to be the last part of this. So this is the base 64 encoded header. This is the base 64 encoded payload, and this is the signature that we generated for this simple message. All right? So we are going to check the challenge later. Disclosure, because GDPR happened in 72 hours, as it was requested by GDPR, but still Facebook can be fined to $1.63 billion because of this leak. It's a huge amount, just because of this leak. Let's compare this value to the value that I'm going to show you at the end of the talk or the session, how much it is in case of Yahoo for 3 billion users. Okay? 50 million, 1.63 billion US dollars, and in case of 3 billion users, how much is it? We'll see. So, challenge time. Please open your Avatar account and go to the personal request application, Facebook application. So I just stop it. I restart it. So the attack model is the same as in case of Facebook. You are going to have two access challenge buttons. The first one, on the left, is going to give you a nice user interface of web page. And the other one is going to be an API. So you have to use, or at least know about that we have an API of this application. So these are the two things you can accept. Now I give you a few minutes to think, and afterwards we are going to move forward. Don't forget the documentation.txt under the downloads section on the right side. Okay, a little help, just to give you some hints. So the first step you have to do is to register yourself. So number one, register an account. ASDF, 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 signing up. And now you have this interface where you can view your profile as, and you can add new movies to your watch list. So these are the features that you should check. And also, another hint, please check the source code of the page, because you are going to find something which can be useful.
check the source code. Yoda. Now create a new watch list. Now settings, save. You can add something to your list. You can view your profile as see. Now check. Okay. Could you check the source code? Did you find the token?
No, I didn't look at the source code.
If you here,
Oh, okay. It's valid.
Okay. Bit of hint. If you go to the profile, which is here on the top right corner, me, if you click on this me, you see that there are two functionalities. First, you can add something to your watch list. And afterwards, you can view your profile as, for example, Lucy. So, do you remember what the attack model was? So we have to use the view as function. First, we uploaded something. This was an item into the watch list. This is the video uploader functionality. And afterwards, we have to check our profile on behalf of somebody else. This is when we get a new access token for somebody. So for example, in that challenge, we have to acquire this access token for Lucy because we are interested in her watch list. So when we check our profile on behalf of Lucy and you check the source code of the application, you are going to see that there is a section where you can find an action to the API active watch list function. And when it was called, you see that there is an access token generated. And the access token is built up, as I said. So we have a base 64 encoded header, a base 64 encoded payload, and afterwards we have the signature. Did you find this?
Which one?
Oh, maybe you are done. Did you? You got the.
This Lucy's access to.
Okay. You are done. I think this is the solution.
But
I should get this correct response.
No, this is just an example response. Try to submit this. Submit to the platform. Copy paste. Go to the platform. To the auto, not the settings, but back to the platform. Yeah.
Oh.
Just check what the form. Maybe you should just delete this curly braces. Okay. So any suggestions? How to move forward? Yeah, first, we just simply do what we did in case of Facebook. So first, we have to add the new movie to the watch list. Done. And afterwards, on this profile page, you will see that there is, in the source code, there is this part. It was dynamically generated. So we logged in, we we created a watch list, and as a result, it's going to return me an access token. And this access token allows me to check Lucy's profile, because this is the misuse in that case, that I acquired an access token on behalf of Lucy, and I can log in with this access token to Lucy's contacts, and I can acquire her watch list. So the only thing left is to use this access token through the API and acquire the watch list. Could you solve this? Okay, great. So please let me know what to do now. So I copy this, right? Okay. Yeah, there is a documentation for the API. So I just save it here. In the documentation let's close this. So in the documentation, what you see is that we can get the watch list with this command, right? So we just simply pass this access token to this call request and push it to the watch list guest. This is the only thing we have to do. So I now try to put together this command. And I try to acquire the URL. Oh, not this one, but the API URL. So it's something like this, right? Who could solve this? You could also solve this. Hands up. Okay, if somebody couldn't solve it, could you solve it? Okay. maybe you missed something from copy paste. That's all. Just one character. And here? Here? The SecPCU API URL, you have to change it.
Oh.
Here. So, can I help? So you have two URLs. The API URL. And you have to place this here. I think it is yours.
Yeah.
Okay. So in my case, this is transporting. Yes. Questions, please, questions. Okay. Russia? Did you solve it? Okay. Why? Why? Would you solve it? Why? Did you try it? Yeah, it's good. It's good. Is it the right URL? This one, right? And documentation. Let's try them. Do you have an editor? That is good. So this is what we have to substitute, right? Okay. So then we have to get the access token, that's all. Right? Did you add the... Okay. Let's try now, okay? Here?
How to copy this to file?
Yes.
Okay. So I did that.
Mm-hmm. Maybe you acquired a bad URL.
do you use? Yes. You have two. This is the API URL.
Okay.
That's what you have to use. Could you solve it?
So he's doing this part right here where he's trying to send the curl request. I forget where you put the actual server.
Yeah, you just use the API. No. So when you start, yeah, exactly. This is what you have to copy there, and watch this /get. So here we are. Oh, sorry. Yeah, this is better because so we just
So we want this address.
yeah. Yeah, and there's I think a watch list. So in the documentation there is something like watch list /get. Could you solve it?
Actually, I am. My header, my authorization header is the problem. Otherwise, I think. I mean, I got the concept down. It's just
You have to just. This is not good. So you have to type the watch list /get. In the documentation, it's there. And the URL, what's your
URL is that one or SiteFlix, yeah, that one. I was just getting it from here. My token was here.
Yeah, that's good, but you go back here.
Sure.
You have two access challenges. And the second one is the API. You have to provide this to this API.
Okay. Still there. Back to VM. And then up arrow, and then
yeah. Could you insert it?
sure, absolutely.
Why? No?
Okay. So, do you understand what happened? Okay, so this was almost exactly the same that happened with Facebook. And you see the takeaway here from is that I wrote some takeaways, for sure. Yeah. So the problem was that as a Facebook mobile app, you could log in with this access token. The second problem was that this access token was generated for somebody else, but not for me. And used two-factor authentication where possible. But this was so the access tokens itself is not a problem. Everybody uses it. I mean, a lot of companies use it because this is how we can scale our application. So problem was here is that they just simply did a design failure at the very beginning. So somehow they had a misconception how to implement it, and afterwards they implemented it in a totally bad way, or they just didn't thought that, they didn't have an idea that this is actually a problem. Okay, let's move forward. British Airways. So British Airways, this is also a really recent attack. So September 6, 2018, the payment system were affected. Almost 400K user accounts were affected. But in that case, the time window for the attackers was a bit more than a week or 2 weeks, like 2 weeks. And in these 2 weeks, what they could do is to steal payment information from the clients while they were paying. So this was not a passive attack. It was an online attack when somebody were just about to pay, and they sniffed the payment information, and afterwards they acquired it. So it wasn't like a database injection or something like this. Yeah. The vulnerability was in our third-party library, again. So they used a modernizer JavaScript library. This library on its own, it was not vulnerable. So this was not what they misused. They could actually inject script into this library that the payment system used, and they could steal the information that they passed to the form, and afterwards they could just store it and pass it to an API where they could store it. So the modernizer script, you see this version, 2.6.2. As I said, this is not a problem with the library. But the attacker somehow could inject the malicious code into this end of this library. And this was the injected script. It's quite simple, as you see. So what they do is when you pay, and you just click on the button, and you release it. So there's a mouse up or a touch end event in JavaScript. You are going to simply read the payment form data, and you create a data URL, and you simply just send it to this baways.com domain where there is an API, and this API just accepts the information that is passed to this endpoint. So the domain, this baways.com, was registered on the 15th of August. So this was an on-demand generating domain through Komodo, and this is what the attackers used. So we do not know any more technical details about the attack. So the only thing we know that this injection happened somehow. So our idea is quite solution could be to inject the code somehow through the content delivery network. So the CDN. If you can hack a CDN that BAV, British Airways used, and you modify the scripts in the content delivery network, they are going to acquire it, and afterwards, there's a problem, right? So content delivery networks, anybody can explain it? Question? Exactly. Exactly. So we'd like to, again, scale up. We'd like to have a high speed of our website, and in that way, we are going to just move the static content to a CDN, the JavaScript, CSS files, and these things, images, and the CDN is going to provide these kind of endpoints which are located close to the user, so the user is going to get the static content at a faster speed. So this is the point in a CDN. So when we hack into a CDN, we are going to manipulate what kind of files are downloaded to the browser of the client, of the user, right? Because this is cached. So we hack into the CDN, we infect something, the files on the CDN, and afterwards the client is going to retrieve the file, not from us, but from the CDN. So if we inject anything into this file, we are going to run it locally. And this is, we think, could happen in case of British Airways. So one solution to protect against this kind of attack is called sub-resource integrity. It means that when we include a script, a remote script, that could be served from a CDF, we first verify the integrity of this file. So the browser is going to block if the integrity is not the one we provide. So this is the attack. So this is the solution. Please try the next one. The next challenge is actually called tutorial. This is a special type of challenge in Avato. We create these kind of challenges for those who are new in a topic, and you will see that there is a bot guiding through the problem. So in that case, the solution, the exercise is not just something that you have to solve on your own, but there is a bot helps you to solve the problem. However, even in that case, we have to do something on our own, because otherwise it would be just a copy-paste exercise. So let's start it. We have 15 minutes left, so what I think would be the best, just to show you the solution, all right? So as you see, this is the payment form. This is something like British Airways could use, right? And the bot tells us, please fill the form with your credit card data. So I'm going to type just any kind of number here. I just type an expiration date, a CVC code, and I'm going to submit it. And I submit it, we change the layout, as you see, and we are going to be requested to create a steal.js file that's going to steal the data that the user submits through the form. So this is the next challenge that we have to do. The solution is now simple. So if we go back, okay, I'll just show you something. So you can, in our tutorials, you can change the layout at any time. So if we go back to the previous layout, you will see that we have the source code editor, and also we have this payment form. So you see, if we check the source code or inspect this item, you see that it is the card number. I don't know if you see it, but there is a card number. So this is the name of this input form. If we move forward and check this one, it's called card expiry. And then finally, the CVC code we inspect is called card CVC. So these are the input fields we would like to get the information from, all right? So I close it. And the script is super simple. We just check whether there is a submit event on the form, because if we check the source code of the application, page source. Okay. So there is a, okay, I don't have to come here, sorry. The index.html is here. It's even easier. So index.html, you see that there's a form, and in the form there is a card expiry, and everything is here. So we are going to go back to the steal.js, and what we do is we are going to hook this event, set the URL to the one that was requested by the bot. We get the input, the value of these input fields, and afterwards we just create an AJAX event and send it to this URL. So that's all what we do, okay? So I click on a deploy button, and the deploy button is going to compile this file. You have to wait a little bit until it realizes, because there is a phantom.js in the background that's going to check the solution. So what we are going to do now is to run this. We are going to run this file called change.js.sh. What it's going to do is to inject this steal.js to the end of snow.js. So snow.js is the one that you see the snowing, and we are actually going to inject this steal.js to the end of this file. So in this way, we just emulate the fact that somebody attacked the CDN and infects the file and is going to add some malicious script. So this is what you saw in case of the modernizer JavaScript file. So we go back. We have a terminal here. In terminal, we can just press enter, and you see that the snow.js was extended by our steel.js file. So this is here. So now we infected the snow.js file. So now the bot asks to fill again the form. So we are going to do this. We are going to just set some expiry, some CVC code. And as you see, it opens the log.txt file where we sent our requests. So this file was created by the steel.js file, and we just store the credit card information and store in this file. In that case, it was the dabase.com/ this kind of URL. So this is how we do this. Now, we are going to help you how to fix this problem, because it has to be a defensive challenge. So what we can do is to use this integrity attribute of the script tag. So when we go back to the index.html, we will see that this snow.js file is included somewhere at the beginning of the file. So if here you see this CDN URL, if we add this integrity attribute and calculate the normal integrity, so the SHA print or fingerprint of this file, and add to this integrity attribute field, the browser is going to block the load of any modified snow.js file. And that is what we are going to demonstrate now. So this is the meaning of sub-resource integrity. So if we go back, the bot asks us to first generate the right SHA signature of the file. So snow.js, we execute OpenSSL. As you see, this is the signature, SHA 384 signature of this file, and that is what we are going to add to this integrity. So I go back, I have to add this integrity SHA 384 dash. Okay? I type here integrity equals SHA 4 dash and the stuff. Afterwards, it tells me to press again the deploy button. So that's what I'm going to do. So now we added this integrity to the index.html. We click on deploy button, and you see that we have to now change again the file. So now we are going to modify once again the snow.js. So this is what we do. So we add once again the steel.js to the snow.js. I execute a command here. You see that snow.js was manipulated once again. So here is our script that's going to steal the information. And what we do now, finally, is to check the Chrome console, what happened. So I open the Chrome console. And if you cannot see this, I try to read, failed to find a valid digest in the integrity attribute for resource credit card.js. So basically, Chrome blocked to load this file because we set up this integrity attribute and we calculated beforehand the right footprint of this file. So this is how sub-resource integrity works. And actually, it's quite nice. I mean, if you don't think of this, you just simply use CDN, right? And it's so easy to tamper your files in this way. So actually, we reached the final state of the bot, so we just simply check on the solution, and we are going to verify that, okay, we solved it, so that's all. Okay? So this was a tutorial on Avato. Other browsers as well. So this sub-resource integrity is not a new feature. Just people simply do not know about this. Okay, so don't trust third-party libraries without verification. Use sub-resource integrity checks, and huge attack surface comes from CDNs that we just simply do not think of. Okay, and some readings. And finally, we have we don't know. We don't know. In this setup, we created a challenge that we have a CDN in order to explain the entire exercise. In case of British Airways, it could be another server. Maybe it was locally. They infected this local server, and that's all. But today, this is a really straightforward attack to attack the CDN directly and do some manipulation. So we have 5 minutes left. I'm going to just quickly go through the exercise. This is going to be homework. To solve this challenge. And this is, I think, the really takeaway from this entire session is that in case of Yahoo, this was the largest breach ever in history, ever. 2016, 200 million users affected. But before that, 2014, 500 million users. And in August 2013, 3 billion users, 3 billion users. So this was the largest breach ever. 3 billion users. And today, October 23, 2018, the fine is Yahoo must pay $50 million US. So just compare it with Facebook. If you remember, 1.63 billion, and it is 50 million. Okay? For 50 million users against 3 billion users. Right? Good. Okay. Let's move forward. But actually, the attack, this 2014 or 2013 attack was only reported by Yahoo, I think, in 2016. So for 2 years, they just didn't tell anything about that there is a security breach. And I think some of their department were about to acquired by Verizon. And just because of this breach, the deal value just decreased with $350 million. So the entire deal value was like 4.x billion. This, I don't know which part of Yahoo. And because of this breach, the deal value just decreased with 350 million. I think this is nothing compared to 3 billion user data, right? So this is, okay. So the problem is that there was no technical details about these breaches. At least I didn't find. Maybe you are more able. I couldn't find it. But we know that there are many, many bugs in Yahoo applications. So we prepared a Yahoo Mail cross-site scripting attack. This is the last challenge. If you are about to solve something on your own, this is something really worth checking. And cross-site scripting, I think I don't have to introduce it. This is a really nice script. 2 more minutes, great. So this is, I never thought that can be a cross-site scripting attack. So if you paste it to the Chrome console, you will see that this actually triggers a cross-site scripting attack. So can somebody decode this? Why? It's really nice. Yes, by why? Yes, you are right. You are totally right. Perfect solution. But even if you have a string and you have an alert, it wouldn't be executed. You must say that, please execute alert, because you don't have script, you don't have JavaScript, you don't have anything right there. Yes, you are right. It's already in the JavaScript, but still the alert function just cannot execute in this way, because you get these values. So just imagine this, that this comes from as a user input, as a text. Okay? This is a text that comes from the user. So the point here, yeah. Yes, you are right, but if there is no script close. Okay, let's try it, okay? Maybe you are right, but as I checked, it didn't work without this dash. So the funniest thing, I didn't know that the dash actually before the alert is going to run the alert. Without the dash, it won't trigger this. So if I go back, but you're right, if it's in the script context, maybe it is true. But if I just simply use the Chrome console and I delete this minus, right? Yeah, actually, yes, because this is an arithmetic operation. But when we add plus, for example, it's going to trigger it. And actually, you were right. The backslash is an escape. So we are going to escape this single quote. And afterwards, it allows us to reach the second alert, which is going to be executed because of this arithmetic operation. Yeah. Okay. But this was just a small info. Yeah. Let's just close it. I finalize the presentation. We are 1 minute over. Okay. So this is going to be a challenge and some best practices. These are coming from, I would say, one of the best cross-site scripting guys in the world, from Mario Heydrich. He gave a keynote at AppSec EU, and also he had his presentation on Confidence 2018. He is the founder of Cure 53. It's a cool German pentest company. They have an annual trend on cross-site scripting. And so 3 types of tools that you can use. And actually, if you use these tools properly, you can evade almost all types of cross-site scriptings. We just simply do not know how and why to use it and when. The previous one, well, I don't know. In content security policy, you can define things like, please don't use eval, or please don't use JavaScript, semicolon. I think this would pass it. Yeah, so content transformation, for example, when you use a web framework, React or Angular or something like this, content sanitization, Python breach, you just filter out all the HTML tags that you wouldn't like to see, and content restriction is actually what content security policy does, so just limit, again, the scope, what a script can do. So, and here comes a favorite thought from him that this was the exercise is dead, we just simply don't get it. This was the title of his talk. He said that our entire ecosystem is bug-centric right now. We keep glorifying the finder in bug bounties, for example, not the fixer. Can we stop doing that? And he's totally right. We have many bug bounty programs. We just adore these guys who find bugs. And the problem is that we do not tackle, just simply do not bother with those who actually fix it, who are the developers. And this is a huge problem. And this is my final thoughts on the entire presentation. In order we have bugs, and for sure that we are going to have many bugs. But if we don't build a strong security culture where the tools and the mindset of people are in place, we are going to fail again, again, again. And this is what Mario also said, that, look, 99%, almost every XSS could have been prevented in the past, and in the future as well. It can be prevented. We just simply do not know how to use the tools. Come on. Or we just simply don't have the context how to configure a CSP properly. So this is a huge problem. Thank you.